I guess. Hello, can you guys hear me? Okay, so fine. So this thing is kindly working right now, I guess. So I don't think I'm going to do much here, but most probably I will. Let's see, mem0. This is the GitHub repo which we want to study. Projects. These are my projects which I did. So by the way, rm-r means here recursive, so it will also go into its one more depth or two more depth, how many depths of folders there are, and then it will just remove everything from that folder. And rm is usually rm are usually there to delete a folder, and if there is some content inside that folder, you need to do -r for recursively delete everything which is inside that. And right now I will try to get clone it to actually understand how this thing actually work. I will use kind of anti-gravity to actually understand what's going on inside that. And let me just open a folder. I want it to remove open mem0. This is inside mem0, and this is the research paper which I want to read about mem0. Let's see what people want. So I guess, do I need to make my screen a little bit bigger? Fine, I guess this is fine. Don't know why it is like this, but okay. So first of all, Mem0 building production ready AI agent with scalable long-term memory. Large language model have demonstrated remarkable prowess in generated contextual coherent response. Yet their fixed context window pose fundamental challenges for maintaining consistency over prolonged multi-session dialogue. We introduced Mem0, a scalable memory-centric architecture that address this issue by dynamically extracting, consolidating, and retrieving salient information from ongoing conversation. Building on this foundation, we further propose an enhanced variant that leverages graph-based memory representation and captured complex relational structure among conversation elements. Through comprehensive evaluation on the Locomo benchmark, we systematically compare our approach against six baseline categories: established memory augmented system, retrieval memory augmented system, retrieval augmented generation, chunk size and k value, full context approach that processes the entire conversation history, open source memory solution, proprietary model system, dedicated memory management platform. Okay, result fine. Chief improvement in the LLM as a judge metric over OpenAI while Mem0 with graph memory achieves 22% higher overall score than the base Mem0 configuration. Beyond accuracy gain, we markedly reduce computation overhead compared to full context approach. In particular, Mem0 attained 91% lower P90I latency, save more than 90%, thereby offering a compelling balance between advanced reasoning and refined code can be found here. Ask Gemini. Human memory is a foundation of intelligence. It shapes our identity, guideline, decision making, and enable us to learn, adapt, form meaningful conversation. Among its many roles, memory is essential for communication as recall, past interaction, infer, preference, and consent. Okay, fine, do fine. Okay, fine. We don't care about human brain. I just wanna know what problem you guys try to solve. Fine. Propose me. Okay, we introduced two memory architecture for agent. Mem0 implement novel paradigm that extract, evaluate, and manage through dedicated module for memory extraction completion. The system processes a pair of messages between either two user participant or an assistant. Mem strengthens foundation by incorporating graph-based memory representation, which memories are stored as directly labeled graph with entities as no relationship as edges. The structure enables deeper understanding of this connection between entities by explicitly modeling Mem0. Let's see what we put right here. Incremental processing paradigm enabling to operate seamless within ongoing conversation. As illustration in figure 2, the complete pipeline architecture consists of two phases. Extraction phase initiate upon ingestion of the new message pair, where empty represent the current messages and empty one representing one. This pair typically consists of user message and assistant response, capturing a complete interaction. This pair typically consists of a in the extraction phase, they actually the previous conversation and the new message. They take these two things and then capturing complete interaction and to establish appropriate context for memory extraction. The system employs two complementary sources: a conversation summary is retrieval from the database. So how does thing work? Message. Last time messages, new extracted memory is given to this fetch summary and past messages. Summary generator. Fetch similar memories. Include nope. No operation. No memory. Update memory. Okay. So basically what we consider summary. So first I need to know the step. To establish appropriate context for memory extraction, the system employs two complementary sources. One, our conversation summary is retrieval from database that captures the semantic content of the entire conversation history, and two, a sequence of recent messages from conversation history, where aim is the hyperparameter controlling the recency. They use a complex naming convention, but okay, fine. There are two M in this, but fine. Support context-aware memory extraction. We implemented an asynchronous summary regeneration where we refresh the conversation summary. This component operates independently of the main processing pipeline, ensuring that the memory extraction process fit from up-to-date context. We must have non-introducing processing delay. Just a second, guys. New messages. I'm not the live begar. This helps provide global thematic understanding across the entire conversation. The recent message sequence of a granular temporal context that may contain detail not considered in summary. This dual context information combined with a new message pair form a comprehensive prompt for the extraction function. Following extraction, the update phase. The update phase evaluates each candidate facts against existing memory to maintain the consistency to avoid redundancy. This phase determines the appropriate memory management operation. For each fact, the system first retrieves the top as semantically similar memories using vector embedding from the database. These retrieved memory along with the candidate fact are then presented to the LLM through a function calling interface we refer to as tool call. What is my YouTube channel name? Ah, finally someone is watching. Videos are empty, but fine, what could be done? After 5 months, I'm streaming again. Update will evaluate each candidate facts against existing memories to maintain consistency and avoid redundancy. This phase determines the appropriate memory management operation for each extracted. So this process for the fact the system will first retrieve the top as semantically similar memories using vector embedding from our database. These retrieved memories along with the candidate fact are then presented to the LLM. Okay, so how the update phase work? This is the update phase, right? Each vector system first retrieves the top as semantically similar memories using vector embedding from the database. These retrieved memory along with the candidate facts are then presented to the LLM. The function calling interface we refer to as tool called the LLM itself determines which of the four distinct operations to execute. Add, trace of the new memories when no semantically equivalent memory exists. Update the augmentation of the existing memory with the information. Delete for removal of memories. And it facts require no modification. Okay, rather than using a separate classifier, we leverage LLM's reasoning capabilities to directly select the appropriate operation based on the semantic relationship between candidate fact. In our experimentation, this is for graph based, right? 10 previous messages for contextual reference and is equal to similar memories for comparison. All language model operate utilize GPT for a mini as a reference engine. It employs dense embedding. The Mem0 graph. G everything is for graph, right? For graph. Graph-based memory approach that effectively captures stories, stores and retrieves contextual information from natural language interaction. In this framework, memories are represented as directed label graph. Fine. Not with represent entities. Represent relationship between entities. Assign semantic type of nodes, Alex, person, city. Okay, in each entity node B will contain three components. Entity type classification that is the entity person, location, event. An embedding vector EV that captures the entity's semantic meaning. Okay. Metadata including creation timestamp. Okay, relationship in our system are structured as triplet. Okay, so this is the node, this is the what is R, where VS and VT is the source and destination entity nodes, and R is the label edge connecting them. Okay, fine. Employs a two-stage pipeline leveraging LLM to transform unstructured text into a structured graph representation. First, the entity and extractor module process the input text to identify a set of entities along with their corresponding type. In our framework, entities represent the key information element in conversation, including people, location, object, concept, even attribute that merit. Okay, so only 14 pages are there, fine. And if we look at this is a simple pipeline. Most pipelines should be like this, right? If we look into this thing. That process the input text to identify a set of entities along with their corresponding type. In our framework, entities represent the key information element in conversation, including people, location, object, event, and attributes that merit present in the memory graph. The entity extract identifies this diverse information unit by analyzing the semantic importance and uniqueness and persistence of the element in conversation. For instance, in a conversation about travel plan, entities might include destinations, cities, countries, transportation modes, dates, any discrete information that could be relevant for future reference or reasoning. I think that just a second, guys. Just a second. Sorry, Lou. Sorry. If I could get into some kind of HFT, it will be fine. A lot of money. Right now, the current company in which I work for, it doesn't give. They gives money, but it's not that good. I'm not really happy with this money. I need a little bit more. Let's see where it goes. Next, relationship generator component derive meaningful connection between. This everything is working right. Yeah. Relationship generator component derive meaningful connection between these entities, establishing a set of relationship triplet that captures semantic structure of the information. This LLM-based module analyzes the extracted entities and their context within the conversation to identify semantically significant connection. It works by examining linguistic pattern and contextual cues and domain knowledge to determine how entities relate to each other. For each potential entity pair, the generator evaluates whether meaningful relationship exists. Yeah. Okay, so how the relationship generator work? Component derive meaningful connection between these entities. Fine. Establishment establishing a set of relationship triplet that capture the semantic structure of the information. This LLM-based module analyze the extracted entities and their context within the conversation to identify semantically significant connection. Okay, fine. It works by examining linguistic pattern, context, cues, and domain knowledge to determine how the entities relate to each other. For each potential entity, the generator evaluates whether a meaningful relationship exists, and if so, classifies the relationship with the appropriate level you've seen. The module employs prompt engineering technique that guide the LLM to reason about the both explicit statement and implicit information in the data, resulting in relationship triplet that form the edge in our memory and then enable complex reasoning across interconnected information. When integrating new information, Mem0 employs a sophisticated storage and update strategy for each new relationship type. We compute embedding for each source and destination entities. Then the system may create both nodes, establishing the relationship. In knowledge graph, we implemented a conflict detection mechanism that identifies potentially conflicting the existing relationship. Then a new information arrives. LLM-based update resolver determine if the certain relationships should be obsolete, making them. Okay, so here's the diagram is. So the first of all, here's what we do. So first of all, given a conversation and some kind of most probably they use LLM. Fine. Here they have mentioned LLM to actually extract the entities. Entities could be anything like a person name or a place, or event could be like driving a car or something. Anything or any car model name, anything could be entity from a conversation is extracted, and then from that entities, each entity is a node, and then and another LLM is used to actually create a relationship between each entities, and then that LLM create a triplet like this is the node V, this is the node U, and then a relationship is from node V to node U. And so basically a node contain two things. A node contain its name, a label, and a dimension, a vector dimension from, and then we create a relationship that this is a relationship, and then there is also a conflict detector, whether it detect that adding this relationship will this thing conflict any existing relationship or not. If it's conflict, then another LLM is used to update to resolve that conflict. Fine. The memory retrieval function Mem0 implement dual approach strategy for optimal information access. The entity-centric method first identifies key within a query, then leverages semantic similarity to locate corresponding node. The entity to be honest, I like this MacBook, to be honest. What this improving recommendation system? Oh, it's Netflix. I have a lot of thing in my reading list, but I never get time to do this thing. But I will do my best. Damn, I just opened Reddit. First, identify the key entity within a query and then leverage semantic similarities to look to conclude nodes in the knowledge graph. If systematically explore both the incoming and outgoing instances from these anchor nodes, constructing a comprehensive subgraph that capture relevant contextual nodes. Upon implementing this, the semantic triplet approach takes a more holistic view by including the entire query. For this, I think we need to see the code, like how this thing will actually work, and then we will kind of understand that yeah, okay, so this is a. I mean, we could actually ask anti-gravity, right, to actually help me. First, I think instead of memo G, I think we should first see this, because this one will be simpler. So we know the entire pipeline, and later they are just evaluating this. I don't think we really care about the evaluation part. Actually, I don't care. I mean, you guys could care if you guys wanna know how this thing is evaluated. You could just see it. But currently, right now, I will do my best to actually. Actually, use the anti-gravity for. Okay, so I think I should have another monitor, but I don't have enough money. Once this YouTube channel generate me enough money, I will try to use it. But right now, I don't have any kind of money with me. So yeah. V3 phase patch pipeline. The system gather context, retrieve existing area. Okay, Mem0 memory. Where is memory? Inside memory. What the hell is Python STK? Is this AI generated code? I think so. Damn, how am I supposed to see this and understand? How big code is this? 2009, 3000 line code is there. Look for his memory class. Where is memory class? the memory class. Because they have implemented the same code in Python and in TypeScript. Okay. I don't know why, but okay, fine. Let's see the memory class. Self memory config equal memory config. Memory factory creates self memory. Okay, so I could just give him the part and then just say I want to see this entire. Just wasting token. Just wasting token, dude. Is there anything flash? Guys, is this thing real? So the president of United States is posting this kind of shit. Fuck. No idea what the hell is going on. Let's see whether my chat GPT works something, do something about it. Okay, let's see. The architecture process here referring to specifically the build phase where the LLM uses tool call determine whether to add the V2 extraction pipeline of Mem0 while the current main branch uses the newer V3 adds only then being overwritten the exact LLM from instruction and the tool call schema you read about in this paper still preserved in the code base. Here's the exol. And I'm reading such a large code base is really tiny, to be honest. Don't know whether what I could find. So this is what the Mem0 code base is. This is what, but dude, the main file is 3000. Like reading 3000 is itself a pain in ass. And then vector stores, Cassandra, don't know. Let's just, but I have Claude, right? Gemini. Let's see how good. Let's see how good I am in this. Okay, so here async memory. So it has async memory and it has a memory. But the memory, This is for entity store. This is for offset entity. Remove memory from entity store. Link entities for memory. And yes, fine. I think this is the main code which I need to read. Search process metadata filter as this is for storing the entity, right? Easily necessary entity storing the first use. But first I need to extract the memory, right? Okay, so this is the word where we this is what we do, right? The link entities for memory function is a core part of the memory graph memory. Okay, fine. Job is to build a graph between specific entities. Okay, fine, and the memories that mention them. Here's the step of entity extraction. When a new memory is self memory ID text. When a new memory is created or updated, this function is called. This function is passed the raw text of the memory. It calls a helper function extract entities. Extract entities is there. So the text which is received is then extract entities from it. Is likely uses LLM and LP to identify all the names, entities, and the types in the text. For example, it's likely, so it doesn't know that what does it do. Type entity text from entities key